Okay, welcome back to another lesson in our series on a tile game. We're doing an overhead tile game. And so far we have done 3 lessons. We're going to do a lesson 4. So I'm going to copy my lesson 3. Again, and remember, I want you to keep some copies of each lesson where we leave off, so that you can go back and use that as a jumping off point, because we're going to look at lots of different ways to accomplish different things, and I want you to have kind of a repertoire of things. So I just copy and paste, and I can rename this now as lesson 4. And I will use my Thonny IDE to go ahead and open those up. I want to make sure that I'm opening up everything from lesson 4. There we go. So main, settings, and we'll do sprites as well. Again, making sure that I'm in lesson 4. Okay, you can see on the outline, which we discussed how to turn that on in the view, I can see that I have both classes there. All right, so let's just run it and see where we left off. We have a tile game here. We can move around. We can run through the wall. Also note that we start behind the walls, or at least behind my wall, the way I've got it designed. And since in this lesson I want to talk about collisions with the wall, that's not very good. We'd be stuck in it. So let's first off move where we start. I'll change this to lesson 4 for my title, and I'm going to start at 5, 5, just to make sure that I'm not beginning inside a wall. And that looks a lot better. Of course, I can still go through the wall. It looks like I'm actually going behind it, so we'll be working on changing that in this lesson. I also would like to have a little bit more of a wall to play around with. I want to have a vertical one. So I'm going to do a for y in range. Again, the letter y doesn't matter. I can use any letter there. But since I'm going to be changing y variables in my positioning, I think it makes sense. Since we were making all of our walls at a y variable 10, I'm going to make this start right below it at 11. I'm going to go all the way to 20 and by 1. Remember, when we get to 20, we won't actually make a wall, so my last wall will have a y position of 19. And I'm simply going to add a wall. We're going to send a copy of our application. That's the self. And we're going to be sending it to the x value of 19, which is where we left off from the last one, comma the y value from the loop. And then we can see how that looks. Oh, sprites dot wall. We'll try that again. Little typo there. Okay, that looks a little bit better. Now I've got a wall going down, and I think I like that. We left off with a y value of 10, so it's 11, 12, 13, 14, 15, 16, 17, 18, 19, right down to the edge. Perfect. Okay. Remember that we're sending a copy of our self because the initializer for our wall wants a copy of the game. And so the game is, where is that game made? It's made down here in our main with the app. App becomes self. All right, so the next thing I want to do is go to our sprites class, and let's change the code for our moving so that we are able to detect and prevent us from moving into a wall. So I don't want to move, okay, if I'm going to collide. So I'm going to say move only if not colliding. So we'll say if not, self dot check for collision. And I'm going to send it the dx and dy that I was given in move. And then I need a colon at the end of the if statement, and now these will need to be indented. Of course, this method doesn't exist yet. We haven't written it, so we're going to go write it right now. Check for collision. We need self always for a method. And we'll go ahead and take the dx and dy, and we'll just call it the same thing. So what I'm going to do is I'm going to loop through every wall in the game. And I'm going to determine if my positioning is inside that wall. So let's go ahead and take a look. And right now we're currently using integer rounding that truncates decimals. So things are going to be a little bit interesting. So I've got just an image of the game here, and I want to look at it. So here's our player as we move around. Our X and Y is the position in terms of cells. And we multiply it by our, I say cells, tiles is what I mean. We multiply it by our tile size for the X and the tile size times the Y position. And then we int that. We int that, meaning that we take a floating point number that has numbers after the decimal point and we just remove them. So if our position says that we should be way over here, where we're basically almost in this tile here to the right, well, when I int it, because I'm not fully in this tile over here, I'm actually going to end up right there all the way to the left, because we don't show ourselves in that new tile to the right until that furthest left point. And remember that all of our points are going to be determined right now by the location X comma Y. So I'm just going to put that here, X, Y, so that you can remember that we have that as our corner. Make that even smaller. There we go. So XY is the upper left-hand corner. I know that's kind of hard to see right now. I could zoom in, I guess. All right, so there it is, that little corner right there. And I want to make sure that when we move, that the movement that I make doesn't cause that upper left-hand corner to be inside this tile. And that makes it real easy for us to do collisions. So I don't care about it overlapping a little, because it has to be all the way equal or to the right of this tile's upper left-hand position. I need to be to the right of it and equal or below it. Now, if I'm to the right of that edge but a little bit above, then that's going to go here and be okay. So we need to make sure that the upper left-hand corner, which is XY, is equal to or greater than the left edge of a wall, and that it is equal to or greater than the top edge. Remember that Y values get bigger going down. All right, one more thing we need to consider is that let's imagine we're looking at this far right square here. So we talked about how we want to see if the upper left-hand corner is to the right of this left edge of the rectangle. We also want to make sure that it is below the top edge. Well, when we do that, we also want to make sure that it's not out here and past it. So this upper left-hand corner XY of my red player is to the left of the left and below the top, but it's still not in the wall. So we need to be to the left of the left, to the right of the left wall, to the left of the right wall, and above the bottom and below the top. So we're going to have to check all four. So let's see how we code that. All right. Let me clear this out here. So we've got check for collisions. First thing I'm going to do is I'm going to create just some shortened variables. So we have, I want to know our X and Y position. So I'm going to make a local variable X that's equal to self.x. That's my player position, because remember, self refers to what we're coding in. We're coding the player because we're in the player class. So self.x plus dx times player speed. So that is going to be the new X location for my player. Now, keep in mind, I'm not actually moving the player. That happens in update. but we are calculating where will our player be. So what we're doing is we're looking at, okay, you want to move here? Well, let's go ahead and pretend that you've moved here and see if you're colliding with any wall. So that's what my x is. It's the future position. So I take my self.x, I take the dx, which is either -1, 1, or 0, so you can think of it as like a direction. Are we going left, right, or standing still? Times that player speed setting from settings. But we need to have it assigned to a tile. So I need to take this whole result here and multiply it by tile size. And I also need the y value. So I'm just going to kind of take this whole thing here, and I'm going to change everything to y. And that gives us our y value. And I need to make sure that that x and y is not to the left of the rectangle for a wall. Remember, each rectangle, each wall has a rect because we did get rect. So I need to make sure that that rect's left, right, top, and bottom don't contain this new xy. Because if it does, I'm going to return true, indicating that, hey, we are colliding. So I'm going to check every wall. So I'm going to do a for each loop. I'm going to say for wall in self dot game dot wall group. So the wall group is what we call iterable. Each sprite group has a list behind it. You can get it by saying dot sprites and it returns the list. But Pygame made it iterable, meaning I can do a for each loop to just quickly go through every single thing in that wall group. So the variable wall here, I could call this anything, but it's a good idea to use a variable name that represents what you're doing. So wall will become each one of the walls in my game one at a time, and I can check every one of them. And if I ever come across one that I'm intersecting, I don't care if I was somehow intersecting more than one, as soon as I'm intersecting one, we're going to say, hey, there's been a collision, you ran into a wall. So I'm going to say if my x position is greater than or equal to the left side of this wall. Well, my wall, remember, has a rect, and that rect contains x, y, but it also contains left, right, top, bottom. So if x is greater than wall.left, and at the same time less than or equal to wall.rect.right. So that means it's in between the left and the right. So the x value is in that danger area. But if as well, we know that the y is greater than or equal to wall.rect.top. Remember, the y values get bigger going down. And it's above the bottom, so the y value is less than wall.rect.bottom. Well, then we've got a problem, and we need to return true. So I just checked each one of those. X greater than the left, X left less than the right, Y greater than top, Y less than bottom. And then I'm going to return true. Now, down here, I'm only going to get here if all walls not colliding, or I'll say it this way, colliding with no walls. Because if we were colliding with a wall, if this statement were ever true, we would have returned true, which means that the code control, the program control, will return back to what called it, which was here. So we would not reach this point in the method. And so if I get this far, I'm going to say return false. Hey, you didn't hit a wall. Now let's go back and look at this method one more time. We are saying if not self.colliding, so that if this returns false, not false becomes true, and so it would read if true, meaning we would go ahead and move the true value. We calculated it here, but we didn't actually change it. Now we're doing plus equals to actually change that XY value. And then in the update, we actually move the rect that positions our player. Okay, so I think that's pretty good. We were using our wall group, which we created back here in main, And remember that each wall is added to that wall group as we create them. So we're good there. Okay, it's time to try this. Now, before we run this, though, you see this star up here by sprites.py. That means I do need to save that file. I need to make sure I save it, or else we'll still be running the old one. So now it's saved, and I can run it, and let's see what happens. All right, I can still move in these directions through the grid, but I can't move down. Let's check here at the edge. Can't move that way or this way. And there we go. So I think we have some good wall collisions. So now you can make a pretty good little maze. So maybe play around with doing that and check out what you can do. It's interesting that I can still move in. If I press down and to the left, I can still move to the left and right, even though I'm pressing down and to the right. So it does allow me to kind of move in both ways. And there we have it. All right, and I think this is a pretty good place to stop here. So we'll stop the video at this time and pick it up in the next lesson.